Picture two coins. Ordinary coins, you could hold one in each hand. We seal each one inside its own little box, and we send the boxes screaming off in opposite directions. One stays here, in a lab on Earth. The other rides a spacecraft out past the planets, out past the nearest stars, light years away. And then, years later, on the very same afternoon, two people each open their box and give their coin a flip. Here, heads. Out there, light years off, tails. They do it again. Tails here, heads there. Again and again, 1,000 times over, and every single time the two coins land opposite. Perfectly opposite. And here is the thing that ought to stop your breath. No message ever passed between them. Nothing travelled across that gulf. There wasn't the time for anything to travel, and yet somehow they agree, every time, on exactly how to disagree.
Sit in that a moment, because you should. It's one of the genuinely strange facts in all of nature, and it's real. Not a thought experiment, not a metaphor. We make pairs like your two coins in laboratories every day, and they do exactly what you just described. The word for what links them is entanglement. And I'll tell you now, before we take a single step, by the end of tonight, that word is going to be both stranger than you fear and tamer than you fear. Both at once. That's the delight of it.
Stranger and tamer. All right, I don't know what to do with that yet, so let me just push on the plain fact. Two coins, always opposite, no message between them. My instinct says, come on, that's easy. That's not spooky at all. They were rigged.
Say more. Rigged how? The coins that always disagree.
The obvious way. Before you sealed the boxes, you looked. You put a heads coin in one box and a tails coin in the other, and you glued them shut. Off they fly. Years later, I open mine. It's heads. Well, of course, the far one's tails. It was always tails. It was tails the whole trip. There's no magic in that. It's just, I found out something that was already decided.
Good. Hold on to that, because it is the sanest idea a person can have here, and it deserves a proper name and a proper picture. Think of a pair of gloves. I take a left glove and a right glove. I seal each in a box without peeking. I mail one to you in Tokyo, and I keep one here. You open yours, you find a left glove, and in that very instant you know, with total certainty, that mine is a right glove.
And nobody's amazed by the gloves. Nothing shot across the ocean the moment I opened my box. The left and the right were fixed the second you packed them. I just learned which was which.
Exactly so. The knowledge travelled at the speed of you opening a box. The facts were sitting there, settled, the whole time. Nothing spooky, nothing fast, nothing non-local. Each glove carried its own little truth. I am left, I am right, sealed inside it from the start. That, right there, is what a physicist would call the prearranged explanation. The answers written down in advance, sealed into each traveller before they parted. Your rigged coins are gloves.
Right, so, case closed? The two coins are gloves. They were set opposite at the start. They flew apart carrying their settled little answers. And I'm getting worked up over nothing.
That is precisely what almost everyone assumed, for about 30 years by the way, that it simply had to be gloves, because what else could it possibly be? But hold on. Before we close the case, let me be a good detective and lay out the other way it could work. Because there are only two sane stories here, and gloves is the first.
Go on, what's the second?
The second is that the coins are not preset at all, that each one is genuinely undecided, truly up in the air, right until the moment of the flip. And then, at that moment, when you flip yours here and it comes up heads, it somehow reaches out to the far one and tells it, "Quick, be tails."
A message. The two coins are talking to each other.
A message. Some influence passing from one to the other at the instant of the flip. arranging the disagreement on the spot. And you can already feel what's wrong with that one.
They're light years apart. For my heads to tell the far coin be tails the instant I flip, that message has to cross light years in no time at all. That's faster than light. That's the one thing you and I have spent our whole lives being told nothing can do.
Nothing can. Not light, not matter, not a whisper, not a nudge. Nothing carries word faster than light. So the talking story asks us to break the deepest speed limit in physics. That's a terrible price, which is exactly why everyone reached, gratefully, for the gloves instead. So of course you take gloves. Pre-arranged answers, settled at the start. No message needed. Done.
And you're about to tell me it isn't gloves.
I'm about to tell you that nature was asked, very carefully, whether it's gloves, with an actual experiment, not an argument. And nature said no, it is not gloves. There are no pre-written answers sealed inside the coins. That's the whole of tonight, and I want to earn it with you slowly, because it is not a thing you should believe on my say-so. What the quantum world actually says.
Then back up and tell me what the coins really are in the quantum picture. Because last time we spent a whole evening on a single one of these things. The qubit, the spinning coin, the arrow that can point anywhere on a sphere, a blend of possibilities that only gives you a plain heads or tails when you finally measure it, and it collapses to one answer.
And you remember the ache we ended on too? That a single qubit, sitting there in its blend, its arrow tilted off to some direction of its own, holds more than you can ever read out. You put a whole rich direction in, you get one measly bit out. One heads or one tails. That tension is going to matter tonight.
I remember. So entanglement is, what, 2 of those? 2 arrows, 2 spinning coins?
2 of them, yes. But here is the move, and it is the whole thing, so let me say it carefully. When you have 2 qubits, you might expect that each one has its own arrow, its own tilt, its own state, and the pair is just the 2 of them side by side, like 2 coins on a table. Sometimes it is exactly that. But quantum mechanics allows something with no counterpart in your everyday world. It allows a state where neither coin has an arrow of its own at all, where the individual coins are blank, featureless, undefined, and yet the pair, taken together as one object, is sharply, completely, perfectly defined.
Wait, say that again, slower. The pair is completely defined, but neither coin is?
Neither coin is. Ask the entangled pair, what will the 2 of you do relative to each other? And the answer is crisp and certain. We will come out opposite, every time. That fact about the relationship is nailed down, absolutely. But ask one of the coins on its own, and what will you do? And there is simply no answer in there to find. It's not that the answer is hidden from you, it's that the coin does not carry one. On its own, each coin is as blank and as random as a thing can be. A perfect, featureless 50-50.
So all of the definiteness has drained out of the 2 coins and pooled in the space between them. The parts are blank, the whole is sharp.
That is a beautiful way to put it, and it is exactly right. In your ordinary world, you learn about a thing by learning about its pieces. You understand the clock by understanding the gears. Here that breaks. You can know everything there is to know about the pair, hold its whole total description in your hand, and it tells you nothing whatsoever about what either coin will do alone. All it tells you is how they lean on each other. The whole is more defined than the parts. There is no word for that in the language you grew up speaking, because nothing you grew up with does it.
All right, but I want to fight you, because that sounds like a fancy way of describing the gloves again. With the gloves, I also know everything about the pair. I know they're opposite, but I don't know which is which until I look. How is your blank coin story any different from just not having peaked yet.
That is the exact question. That is the million-dollar question, and you found it in about a minute. It is the question that a very great physicist finally figured out how to put to nature directly. Because you're right, from the outside, the coins carry sealed, opposite answers I haven't read yet, and the coins carry no answers and only the relationship is real, look identical. Both give you opposite coins every time. How on earth could you ever tell them apart? For 30 years, the smartest people alive thought you couldn't, that it was a matter of taste, of philosophy, of temperament, and not a thing you could ever settle in a lab.
And let me guess, someone found a way to settle it.
Someone found a way to settle it. But before we get to him, I have to take you back and let you feel why the smartest man of the age bet, with everything he had, on the gloves. Einstein's discomfort.
This is Einstein.
This is Einstein with two younger colleagues in the middle of the 1930s. And you have to understand his position because it was not stubbornness. It was principle, and the principle was gorgeous. Einstein looked at this business of the blank coins and the sharp pair, and he said, "This cannot be the final story." And he built an argument, a genuinely sharp one, to show that quantum mechanics, as written, must be incomplete. Missing something.
Incomplete how?
Like this. Take your entangled pair, flying apart. Now, while they're already light years separated, you measure your coin, here, and it comes up heads. In that instant, you know for certain the far coin is tails. No doubt at all. Now, said Einstein, be reasonable. The far coin is light years away. Nothing I just did here could possibly have reached out and touched it, not without breaking the speed of light, which we refuse to do. So if I can now predict, with total certainty, that the far coin is tails, and I did nothing to it, then that tails must have been a real fact about the far coin all along.
That's the glove argument, dressed up. If I didn't touch it, and yet I know it for sure, then it was already true.
Einstein called that settled, pre-existing truth an element of reality. And he said, quantum mechanics doesn't have one. Quantum mechanics insists the far coin was blank, undecided, until the measurement. But I've just shown you the tails was real all along. So quantum mechanics is missing that element of reality. It's incomplete. There must be a deeper layer underneath, extra information sealed into each coin from the start that the theory just isn't telling us about.
The instruction sheet. Each coin flies off carrying a little sealed envelope of pre-written answers, and quantum mechanics is just too coarse to see the envelope.
The physicist's name for that sealed envelope is a hidden variable. Hidden because the theory doesn't show it to you. Variable because it's the extra fact that decides the outcome. And notice, Einstein's whole argument leans on one assumption so reasonable you'd hardly bother to state it, that what I do here, to my coin, cannot instantly change the real state of a coin there, light years off. Things that are far apart mind their own business. He called the alternative spooky action at a distance, and he said it with a sneer, because to him it was obviously absurd.
And honestly, he sounds right. That all sounds airtight to me. I did nothing to the far coin. I can predict it perfectly, so it was already decided. Where's the hole?
There is no hole in the logic. That's what makes it so good. Einstein's argument is valid. If far apart things mind their own business, if there's no spooky action, then the answers must be pre-written and quantum mechanics is incomplete. That if-then is bulletproof. For 30 years it sat there, unanswerable, and most physicists shrugged. It's a matter of philosophy, isn't it? Maybe there are hidden envelopes, maybe there aren't. You can't open the coin to check without measuring it, and measuring destroys the very thing you'd want to see. So who can say? Back to work.
A stalemate. Untestable. Just taste.
Just taste. And that is the sleepy, resigned state the whole question was in, until a physicist named John Bell, decades later, in the 1960s, did the thing nobody thought could be done. He found the crack. He found the one place where the answers were pre-written and the answers were not, stop looking identical, and start giving different numbers. Numbers you can go and measure. Bell's beautiful idea.
Okay, this is the part I've been waiting for. How? If both stories give me opposite coins every single time, where does the difference hide?
Here's Bell's move, and it is so simple it's insulting. Everyone had been flipping the two coins the same way. Same question, both sides over and over, and of course, both stories agree perfectly when you always ask the same question. So Bell said, "Stop doing that. Ask different questions. Measure the two coins in different ways. Turn a dial to a different setting on each side, and don't always match the settings up. And then look at the pattern of agreements and disagreements across all the different combinations. Because the pattern across mismatched settings, is where the sealed envelope has to show its hand."
I'm going to need a machine for this. Give me something concrete.
Let's build one. Two boxes far apart, yours and mine. Into each box flies one coin of an entangled pair. Each box has a dial on the front with 3 settings. Let's call them Setting A, Setting B, and Setting C. You pick one, you drop the coin in, and the box does its measurement and flashes a light, red or green. That's the whole machine. You choose a dial setting, you get a color.
3 settings, 2 colors, a light. Got it. And this is the same, always opposite, magic as the coins.
Same magic, wired up for a lab. Now, 2 facts about this machine. 2 things we simply observe when we run it a great many times. Fact 1. Whenever you and I happen to set our dials to the same setting, both on A, say, or both on B, our lights always flash the same color. Both red or both green. Every single time, without fail, when the dials match, the colors match.
Hang on, the opening coins were always opposite. Now your lights are always the same.
Same phenomenon. I've just painted one of the boxes the other way round. Swapped which color I call which. Opposite coins, matching lights. It's one lock, described from 2 sides. Don't let it snag you. The point that matters is matched dials, perfect agreement. Guaranteed.
Fine. Matched dials always agree. That's fact 1. What's fact 2?
Fact 2. Now we let the dials disagree. We each spin to a setting at random, independently, not looking at each other. Run it a huge number of times, all the different combinations mixed together, and we ask, overall, across all those runs, how often do our 2 lights flash the same color? And the answer that comes back from the machine is half the time. Take all the runs together, and the lights agree exactly half the time.
Matched dials always agree. Random dials agree half the time. Those are my 2 facts.
Those are your 2 facts. Now, Einstein's story. The sealed envelopes. Let's take it completely seriously and see what it demands. If each coin flies out of the source carrying a pre-written instruction sheet, what has to be written on that sheet?
It has to have an answer ready for whichever dial setting I might pick. I could turn the dial to A or B or C. The coin doesn't know which I'll choose, so the envelope has to say, if she asks A, flash red. If she asks B, flash green. If she asks C, flash whatever. A color for each of the 3 settings, a little table.
A color for each of the 3 settings, sealed in before it leaves. And here's a thing that table has to satisfy because of fact 1. When you and I both dial the same setting, we always get the same color. So your coins table and my coins table must be identical. If your sheet says A means red, mine had better say A means red too. Otherwise, the times we both pick A, we'd sometimes disagree, and we never do.
Right, the two envelopes carry the same table. Otherwise, they'd get caught out whenever we matched dials. So really there's one shared table and both coins carry a copy.
One shared table, two copies, sealed and flown apart. Now here is where you do the work, and I just watch. That table assigns a color, red or green, to each of the three settings, A, B, C. I want you to think about what the table can look like and how often, for a given table, you and I would end up agreeing when we spin our dials at random.
Okay, let me think. A table is just three colors, one for A, one for B, one for C. So the tables come in kinds. There's the kind where all three are the same color, red, 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 or green, green, green.
Start there. Suppose the shared table is red, red, red. You and I each pick a setting at random. How often do our lights agree?
If every setting says red, then no matter what I pick and no matter what you pick, we both flash red. We agree, always, every time, because there's only red on the whole table.
Every time. Same for all green. So the uniform tables, all one color, give agreement every single run. Now the other kind.
The mixed kind. Two of one color, one of the other. Like red, red, green. A is red, B is red, C is green.
Take that one. Red, red, green. You and I each spin to a random setting. Now walk it out. How often do we agree?
Let me count the combinations. I pick one of three, you pick one of three, so there are 9 equally likely pairings of our two dials. We agree when your setting and my setting carry the same color on the table. The reds are A and B, the green is just C. So we agree when we've both landed among the reds, or we've both landed on the green.
Keep going. Count them.
Both among the reds, that means both of us on A or B. The pairings, you A, me A, you A, me B, you B, me A, you B, me B, that's 4. And both on the green, that's only you C, me C. That's 1 more, so 5 pairings where we agree, out of 9 total.
5 out of 9. And what about the other kind of mixed table? Red, green, green, say, or any 2 and 1 split?
It's going to be the same by symmetry, isn't it? One color appears twice, the other once. 2 settings share a color, one is the odd one out, so the count comes out the same shape. 4 pairings inside the pair that matches, 1 pairing on the lonely one. 5 out of 9 again. Any mixed table gives 5 in 9.
So now put it together. Look at what you've just proven. Every possible table, every sealed envelope nature could ever write, falls into one of 2 kinds. The uniform tables agree every time, 9 in 9. The mixed tables agree 5 in 9. There is no third kind. So no matter what mixture of envelopes the source sends out, run after run, some uniform, some mixed, whatever recipe you like, the overall agreement rate cannot possibly come out below.
Below 5 in 9. Because the worst the envelopes can ever do is 5 in 9, and that's only if every single one is mixed. Any uniform ones only pull the average up, so 5 in 9 is a flaw, a hard flaw. If the coins carry sealed answers, they must agree at least 5 times in every 9. They can't help it, it's just counting.
It's just counting. There's no physics in what you just did. No quantum anything. It is pure, cold logic about sealed envelopes and dials. If the answers are pre-written, if each coin minds its own business and just reads off its own table, then agreement can never dip below 5 in 9. That is Bell's flaw. And now
you tell me what the machine actually does. Fact 2. The real machine, random dials, agrees half the time.
half the time.
Half is less than 5 in 9.
Half is less than 5 in 9.
So the machine breaks the floor. The real coins agree less often than any sealed envelope could ever allow. They dip below the floor that pre-written answers can't dip below.
They dip below it. And that floor was not a quantum prediction, remember. It was the envelope prediction. It was Einstein's story, worked out honestly to the last decimal. Einstein's story says, at least 5 in 9, guaranteed, no wiggle room. Nature says, half. Nature comes in under the floor that the sealed envelopes built. And there is only one way to read that.
There were no envelopes.
There were no envelopes. There is no sealed table of pre-written answers inside the coins, because if there were, the agreement could not possibly have come in as low as it did. The coins were not gloves. The tails was not sitting there, a settled fact all along. Einstein's beautiful, bulletproof, reasonable argument had a false assumption buried in it, and nature has told us, by breaking the floor, exactly which assumption was false.
Which one? Walk me right up to it. His logic was, if far apart things mind their own business, then the answers are pre-written. We've just shown the answers are not pre-written. So
the if has to go. Far apart things do not, in this precise sense, simply mind their own business. The assumption Einstein never thought to doubt, that what happens at your box can depend only on your coin and your dial, and not one whit on my faraway choice, that is the assumption nature has struck down. Physicists call it locality, and this is the heart of what Bell proved. No story in which each coin carries its own private, preset answers, minding its own business, can ever reproduce what the machine actually does. The world is not locally prearranged, full stop.
And this has actually been done. Real boxes, real coins, real dials. This isn't a chalkboard argument.
This is the part I most want you to trust. It has been done, and done, and done again, for decades, with more care each time, the boxes moved farther apart, the dial settings chosen faster and later, and more randomly, precisely to slam shut every clever escape hatch anyone could dream up. What if the boxes secretly signaled, moved them light apart, chose the settings too late for any signal to cross? What if the source was in cahoots with the dials, chose the dials by starlight from opposite ends of the sky, every loophole hunted down and nailed shut? And every single time, without exception, nature breaks the floor. It is as solid as anything in physics. It earned a Nobel Prize. The world is not locally prearranged, and we are as sure of that as we are of almost anything. But nobody's phoning anybody.
Okay, I need a second because I think I just agreed to something enormous. You're telling me my coin here genuinely had no answer in it. It was truly blank, undecided, until I looked. And the far coin was truly blank too. And yet the instant I look and get heads, the far one is committed to tails. So, didn't something just travel? Didn't my measurement here reach out and shove the far coin? That's the spooky action Einstein hated. Did we just prove the coins really are talking faster than light?
This, right here, is the needle the universe threads, the most beautiful part of the night, so slow all the way down with me. The answer is no. Nothing travelled. No message passed. You cannot use this to send so much as a single bit faster than light, and I'm going to prove it, standing at your own box.
Please, because it sure feels like I just sent something.
Then look at what you actually see at your box. Forget the far one entirely. You sit at your box, you run it over and over, dialing your settings, and you write down your own colours as they flash. What does your list look like?
My list is red, green, green, red, green, red, red. I mean, it's just a jumble. 50-50, random, a fair coin.
A fair coin, utterly featureless. Now, here is the whole thing. Is there anything I can do at my faraway box? Any dial I can turn, any choice I can make, any moment I choose to measure or not measure at all, that changes your list, that puts a pattern into your jumble, that makes your reds come more often or clump together or spell something?
Let me think it through, honestly, and not just take it. No, there can't be. My own colours are 50-50 no matter what. You just told me each coin alone is a perfect blank. So whatever you do over there, my stream stays the same boring fair coin. I can't tell, just from my list, whether you've measured yours or which dial you used, or whether your box even exists.
You cannot. Your list is pure patternless noise, and it stays pure patternless noise, whatever I do, however I do it. And that is the death of the faster-than-light telephone. For me to send you a message, I'd have to be able to do something here that makes a difference there. Make your reds cluster, tap out a code. But I can't reach your list. Nothing I do bends it. So there is no way, none, to push a signal through this connection.
But the correlation is real. The coins really do come out opposite, always. So where does that live if it's not in my list and not in yours?
It lives in the comparison. And this is the exquisite part. Your list alone is noise. My list alone is noise. The impossible pattern, the flaw-breaking, envelope-defying correlation only appears when we bring the two lists together and lay them side by side, run against matching run. And to bring the lists together, someone has to carry one list to the other. Phone it, mail it, fly it over. By ordinary means, at ordinary speed, slower than light.
So the spookiness only shows up after the slow message arrives. Until my list and your list are physically in the same room, there's nothing to see. Two piles of coin flips. The magic isn't in either half, it's in the overlay. And the overlay can't happen faster than a courier can travel.
There it is. That is exactly it. The correlation is genuinely there, genuinely non-local, genuinely impossible for any sealed envelope world. And it is also completely useless for sending a message because you can't see it from one side, and assembling both sides needs an ordinary, light-speed limited trip. Einstein's speed limit survives, perfectly intact, even though his hidden envelope intuition lies in pieces. The universe took away his gloves and left his speed limit standing. It threaded the needle.
That's genuinely dizzying. It's spooky and it's law-abiding at the same time. Let me try to break it one more way, though. Which measurement happened first? If I measured a hair before you, doesn't mine cause yours? Isn't there a first mover?
Push on that and it dissolves in your hands, which is the final tell that you've been asking the wrong question all along. When the two boxes are far enough apart, the order of the two measurements isn't even a fixed fact. Someone flying past one way would say yours came first. Someone flying past the other way would say mine came first. And neither is wrong, because for events that far apart, which came first genuinely has no single answer. So if you insist yours caused the far one, someone else, just as correct as you, insists the far one caused yours. The cause evaporates.
So there's no first mover. Neither one causes the other. They just come out related as one thing, and asking which end reached out to the other is a malformed question.
A malformed question. The cleanest way anyone has ever put it. The pair is a single, spread-out object. Not two coins with a wire between them, one yanking the other. One object, whose parts happen to be light years apart, whose relationship was fixed the moment it was made, and whose individual outcomes were never fixed at all until you looked. Stop asking who signaled whom. Nobody signaled anybody.
And this is the point where I promise I want to say the word consciousness, or telepathy, or the universe is all connected, man. because that's where every late-night version of this goes.
I know it is. So let me put it down hard, because this is where the woo grows. This is not telepathy. It is not minds touching. It is not a hotline you can whisper through, not a cosmic web you can tug on for good luck, not a thing you can feel. We just proved you can't send a single bit through it, so it certainly can't carry a thought or a healing or a hunch. It is a precise, fragile, measurable statistical fact about pairs of particles that shows up only when you carefully compare two lists of laboratory results. Strip away the mysticism, and what's left is stranger than the mysticism ever was, and a great deal more disciplined. The fuel.
So if it's not a telephone, and it's not telepathy, and I can't send a bit with it, what is it actually good for? You keep hinting it's the fuel for the whole rest of the series, but you've just spent 20 minutes telling me all the things it can't do. What's left?
Everything. Cast your mind all the way back to the very first idea we ever built together, the one this whole season hangs from. Information is physical. Information isn't some abstract ghost floating above the world. It's carried by physical stuff. It obeys physical law. It costs energy. Well, entanglement is a kind of information that has no home in the classical world at all. It's a physical resource, like fuel in a tank, and it is a resource nature never let you have before.
A resource, meaning something I can make and store and then spend to do a thing I otherwise couldn't.
Exactly that. Make it, keep it a little while, spend it. And here's the crispest way I can tell you what makes it worth spending. Think back to the gloves, to a plain, honest, shared secret. You and I could each carry a sealed envelope with the same random string inside. A shared secret, genuinely useful. We build real things with them. But Bell just proved that entanglement gives you correlations stronger than any shared secret could ever produce. Stronger than any sealed envelope. That gap, the extra correlation, the part that breaks the flaw, the part no classical secret can imitate, that is the new stuff. That is the fuel.
So the fuel is exactly the spooky part. The flaw-breaking excess. The bit of correlation that has no classical explanation. That's not a curiosity. That's the tank of gas.
That is the tank of gas. And now let me plant the thing that's going to power the next several nights without spending it yet. Last time, we marveled at a single qubit. One arrow on a sphere holding more than you can read out. But one qubit, honestly, is a curiosity. The real fire starts when you have many qubits and you let them become entangled with one another, linked into one great shared object, the way our two coins were linked, but now dozens or hundreds or thousands of them, all woven together.
And when you link them up, the number of possible arrangements of the whole bundle explodes. I remember you teasing this. A handful of qubits, a handful of combinations, a modest crowd of them, and the count is bigger than anything you'd want to name.
Grows like 2 multiplied by itself, once for every qubit you add. So by the time you have a modest crowd of them, the number of arrangements the entangled whole embraces is larger than the number of particles in the sky. And entanglement is the thread that stitches all those arrangements into one linked object, instead of a heap of separate coins, each doing its own thing.
And now I have to be careful because I can hear my own inner hype man about to say, so it just tries every arrangement at once and that's why it's fast. And you warned me last time that sentence is a lie.
Guard that instinct fiercely. It will save you from 90% of the nonsense written about this subject. No, it does not try every answer at once. Holding a vast, linked space of possibilities is not the same as reading out the answer you want. Remember, you only ever get one measly outcome when you look. The entanglement gives you the vast, linked canvas. But painting the right answer onto it, getting the wrong possibilities to quietly cancel themselves out, and the right one to stand up and shout, That takes a second ingredient, one we have not met yet. And that ingredient, the real magic, the thing that turns this fuel into an actual engine, is exactly where we begin next time.
That's the pin, isn't it? You've handed me the fuel tonight, the strange, floor-breaking, unfakeable linkage, and you're going to make me wait to see it lit.
I'm going to make you wait, because a fuel you don't understand is just a dangerous puddle, and now you understand it. You know what entanglement is, correlation with no classical explanation. You know what it is not gloves, not a telephone, not telepathy, not a way to break the speed of light. You've watched, with your own reasoning, the sealed envelope story fail by the numbers. That is the honest foundation. Everything we build from here, every computation, and much later, ways of sending and protecting information that will look like outright sorcery, all of it burns this one fuel. This is the tank the whole rest of the series runs on. Unsettling delight.
You know what gets me, sitting here at the end of it? At the start of the night I had two comfortable stories, and I liked them both. Either the coins were rigged in advance, gloves, or they were shouting across the void faster than light. And the whole thing tonight was you taking away both. It's not gloves, Belle's floor breaks. And it's not shouting, I can't send a single bit. Every door I reached for, you closed. And I'm not left with nothing. I'm left with a third thing that doesn't fit in my head. A pair that's one object, blank at each end, sharp in the middle, spread across light years, and perfectly law-abiding while it does the impossible.
And that, exactly that, is the feeling I promised you at the top. Not fear, not mysticism, delight, with a shiver in it. The world is not locally pre-arranged. Reality does not keep all its answers written down in advance in a way that lets every little thing mind its own business. That is a genuine, tested, Nobel-honored fact about the universe you live in, and you can carry it around in your pocket now. It cost us Einstein's most cherished intuition to learn it, and in return it left us this, a resource, real and physical and spendable, sitting in the gap between two coins that always know how to disagree.
The dark between the coins.
The dark between the coins. That's where the fuel lives. And next time we finally strike the match. We take these linked qubits and we learn the one trick that turns a vast blank canvas of possibility into a right answer standing up out of the noise. The thing every quantum algorithm is secretly made of. Bring your sharpest doubts. You'll need them.
Wrong answers erasing themselves. You said that phrase once and wouldn't explain it. That's the match, isn't it?
That's the match. Good night.
Good night. And I'm taking the coins home with me. Both of them. Or the one object, whatever it is. I'll never look at a pair of gloves the same way again.